Good afternoon, everybody. Welcome to the second day of our technical track. Hope everybody had a good lunch. See, there's still some folks filtering in. Here today to talk about code signing certificates, and specifically the application of code signing to non-executable files. So I think it's something that a lot of folks haven't seen too much of. We have some really good examples of attackers using this in the wild. So I'm Barry Vangerink. I'm the technical director on our advanced practices team. We've seen a lot of my colleagues on the team brief so far this week. I hope you guys have enjoyed some of those talks. Real quick show of hands, how many folks are CISPs in the crowd? CISP certified? Seeing a few. Okay, so you should be able to explain this next slide to everybody. My slide works. There we go. So, PKI. This is the standard diagram that you're going to get in your CISP textbook on PKI. It's very obtuse, does not make a lot of sense. I'm kind of assuming for the rest of this talk that folks have like a passing familiarity with PKI. Basically, PKI is the standard by which you can have two hosts or two pieces of data that did not know anything about each other verify something about each other. That's the 1,000-foot view. Specifically, the PKI implementations that most folks in here will be familiar with are TLS, SSL, and code signing. So SSL is probably the one that most folks look at on a daily basis. What you're looking at here is a public key of a certificate pair. And this one is specifically used to sign a file. So the standard that defines what this looks like is X509. And if I'm losing you guys, there's going to be a lot of standards in the first 10 minutes, but trust me, it's worth it. So what you're seeing here is the top portion of a public X509 certificate. This contains the public key for the cryptographic pair for a code signing, very similar to what you're going to see for a SSL certificate. Some of the key differences between what you're going to see for code signing versus SSL is things like extended key usage. SNI is something you'll see in SSL that you will not see in a X509 certificate for code signing. So there's a lot of different implementations, but at its core, it's the same standard. So what you're seeing here is a serial number, issuer, subject, validity date. These are all metadata on the code signing pair, in this case, the public certificate, that are really useful for threat intelligence purposes. And we'll talk a little bit about a few of these. So for code signing, if folks aren't familiar, the most popular implementation, the vast majority of signed binaries are using Microsoft Authenticode. This is Microsoft's standard for code signing for portable executables in Windows. If folks are more familiar with SSL, there's a few key differences on how things are handled for SSL certificates versus code signing. Most importantly, revocation. Revocation for SSL certificates is handled directly by the certificate authorities and, at this point, the browser companies, so Mozilla for Firefox, Google, and Microsoft. This has been a change over the years. It used to be only handled by the CAs through certificate revocation lists, and we'll talk a little bit about why that's changed over the years. But for code signing, Microsoft basically handles all code signing revocation for Authenticode. It's important to consider when you're looking at malware that might be signed with an expired certificate versus a revoked certificate. A file that's signed with an expired certificate will still be recognized as valid by Windows as long as it was signed at a time that the certificate was valid. So if you peel it back a little, it actually makes a lot of sense. You don't want an old file to all of a sudden not be recognized as valid by Windows just because the certificate expired. So it's a backwards compatibility thing. But it's an important thing to keep in mind when you're looking at code signing certificates in Windows. And the final point that's real important here is I cannot use a certificate that was issued for an SSL server to sign code. This is defined in a standard called extended key usage, which is part of the X509 spec. This was not always the case. So we'll talk about our first kind of real-world case here. Many years ago, so this was in 2010 and 2011, a company in Malaysia was issuing SSL certificates using a RSA 512 key length, which sounds real short because it is. So if folks are familiar with factoring, it's basically an idea that I can extrapolate a private key of a public-private key pair through a brute force method, just basically try every possible key. RSA 512, even at the time, was known to be very vulnerable to brute forcing. However, this CA in Malaysia was still issuing RSA 512 keys, so that was the first problem. An attacker that we track as 290, UNC290, also known as Dark Hotel or Fallout Team, got the public keys for these SSL servers, so just website SSL certificates, and was able to factor them and get the private keys. So that was the first part of the attack. Second part of the attack is the CA did not maintain CRLs. So they had no way to revoke these certificates once they knew they were being abused. This is one of the inciting incidents that caused Google and Mozilla to start maintaining their own certificate revocation mechanisms through things like OCSP. And the final issue in this incident was the certificates did not have extended key usages specified. So the part of the spec that allows you to define what certificates are allowed to be used for was missing in these certificates. So the attackers were able to factor the SSL certificates and use them to sign malware with code signing. So it's a really kind of interesting case. Mozilla ended up totally revoking trust from this CA pretty much immediately. So what that did is invalidated all of the certificates that they had ever issued. So kind of a nuclear option. But I'd encourage people to check out research from F-Secure and Fox IT at the time of this incident in 2011 that really documents the blow-by-blow very well. So the reason I'm bringing this up is it's not something we're likely to see again, but it shows some of the weaknesses in this trust mechanism that the CAs have a lot of trust in this whole mechanism for code signing and SSL. So the CAs can be a real weak point. So why do I bother signing code? Signing code, whether it's authentic code or any of the other mechanisms we're going to talk about, really only ensures two things. It ensures that the file has not been modified after it was signed, that the checksum's the same, and it verifies the source of the code. So we can verify that whoever's name is listed on the subject of the certificate is the person that signed the code. So as an attacker, why do I want to sign code? Primarily because of a lot of built-in mitigations in Windows that signed code is allowed to bypass. So as of Windows Vista and Windows 7, any kernel driver that's run by Windows has to be signed. And they've even extended that a little bit in Windows 10, version 16.07, that it has to be signed as an extended validation certificate, which is basically a certificate that has many additional validation mechanisms as to the identity of who the certificate's getting issued to. And we'll talk a little bit more about that later. So the kernel driving is important in that the malware that most people may be familiar with are network rootkits, such as Photo and HiKit, and they'll hook a network driver to listen for incoming packets, so they can be configured as a passive backdoor. Since those drivers are directly interacting with hardware, Windows says that they have to be signed. And this is actually some of the first cases of signed malware that we've run into at FireEye, certainly some of the most prolific, where attackers were acquiring code signing certificates in order to sign these drivers to allow those backdoors to persist and bypass those Windows mitigations. Another common, I shouldn't say common, but one we've frequently observed technique for using signed code is for software updates. So folks have read the APT41 report and several other reports over the years. In order to do a quote-unquote evil updates attack, which is push out malware through legitimate software's update mechanisms, one of the controls that's frequently in place for the software is to check that it's signed, and it's signed by the same publisher as the software. So in order to abuse that mechanism to push out malware as an update, you got to steal or co-opt the publisher's certificate and sign your malware with it. So incredibly effective technique, and APT41 used it to pretty incredible effect to target wide ranges of users around the world. Another reason that an attacker might want to sign their code is whitelisting. So certain environments may only have allow code to be run that's signed by a certificate that they trust. This could be a whitelist. This could be list managed by Microsoft. They may also attempt to masquerade as legitimate software. So similar to the software update technique. If you have a really controlled environment and you're saying, hey, I only want to run binaries on this Windows DC that are signed by this certificate authority or with a certificate issued to this subject, you can bypass that control if you have the right certificate to sign your software with. And finally, security software bypass. This is similar to what I talked about with the driver loading. There's a lot of mitigations in place in Windows, and if folks are red teamers or pen testers, they're probably familiar with a lot of this stuff. But things like user account control and smart screen, like if you've ever downloaded an unsigned file and tried to run it on a modern version of Windows, you'll get a big splash screen that this is an untrusted publisher. That's what this is looking for. So a file that hasn't been signed, you're going to get a big smart screen splash that this is an untrusted publisher. And that varies to different degrees based on things like the extended validation certificates I talked about before. And macOS has a similar version of this. It's a little bit more A and B. It's either run signed files or do not allow signed files, and it's called Gatekeeper. So going outside of the Ps, talking about some of the other things that we can sign. Microsoft Office has had a group policy for a long time to only allow signed documents and signed macros to be execute macros in the environment. The reason you see this is because if we really think about what VBA macros are for, I'm sure most of us in this crowd are thinking of it only in the context of an attacker is going to compromise endpoints with VBA macros. But there's a reason that VBA macros exist, and Microsoft has the feature, and it's still in Office, is the vast majority of the use is legitimate. There's a lot of companies and work processes that are dependent on macros and spreadsheets and Word documents. So you want to have some sort of ability to verify the source of those macros and allow them to run in your environment. That's where the signed macros and signed documents come in. You can set up your environment so that it will only execute macros from documents that have been signed by a trusted certificate. Similar cases exist for JavaScript and VBScript run directly by Windows Scripting Host. This is actually a feature that's been in Windows Scripting Host for a really long time, 2011. You can set in registry and via GPO set this registry key to only allow signed scripts to be run by Windows Scripting Host. And we'll go into some really cool examples of malicious JavaScripts later on. And finally, PowerShell. PowerShell actually has had this built in from the get-go. The reason we don't see malicious PowerShell very often, and we don't really even have a single confirmed sample, is because it's very easy to bypass. PowerShell exe at runtime, when you're running a PowerShell script or PowerShell code, you can specifically tell it to bypass your set execution policy, which is where you would set the flag to only run signed scripts. But what this gives us is a weak signal, right? So if we have the proper detection in place, we can alert anytime we see PowerShell run with this execution policy bypassed, which in a controlled environment could give us a good indicator that something fishy is happening. So here's all the standards and documentation that went into that first part. There's a lot of standards that Microsoft has set, particularly for Office. A lot of open standards, so things like OpenOffice, LibreOffice use the same standards for how they deal with digital signatures. So if folks really want to read a few thousand pages of Microsoft documentation, here are the links. So how do attackers get these certificates? Up until 2 or 3 years ago, the primary source of attacker code signing certificates that we saw being utilized in real-world attacks was certificate compromise. So attackers would compromise a valid software company, get into their code signing environment, and sign their malware with that company's code signing certificate. The code signing environment in software publishers and hardware suppliers can vary widely. Some of the most secure implementations will have something called a hardware security module, which actually contains the private key, and it's a physical device that's secured, and it sits in a safe when you're not using it, and it's a really tightly controlled process. We have seen attackers be able to compromise certificates in those environments because at some point that hardware security module has to get hooked up to the build server where you're signing your official code, and at that point the attacker has access to it and can use it to sign their malware. So frequently I've seen this abused to get into the software update mechanism. So I talked a little bit earlier about how APT41 did this in several cases, which we outline on the side here. Some of the earliest cases are things like Stuxnet and Dooku, both of which utilized code signing certificates from hardware suppliers in Asia. APT17, a case that a lot of folks aren't familiar with in the West outside of Korea, was ESTsoft, which is a very large software publisher in South Korea. ALZip is their kind of flagship product. APT17 in 2010 was able to subvert their software update mechanism using code that they had signed within their environment and pushing out malicious updates to folks in South Korea. A lot of other cases here that are public, Bit9, Adobe, all the APT41 stuff, all this stuff has great stuff on the internet if you're interested in the kind of mechanics of it. Adobe issued an alert on this several years ago. It was an IAS filter that had been signed by APT18 using a compromised certificate. The Bit9 case was also very interesting. Bit9 now, Carbon Black, has a really excellent blog post. They did a post-mortem on that, and they talked a little bit about how they saw the malware that was signed being used in attacks. So the big takeaway for the certificate compromise, this is basically the most difficult possible way to do this. You have to have a pretty significant pre-intrusion before you're even signing your malware that you're going to use for something else. You have to compromise one of these companies. You have to get into their code signing environment. If it's something that's using HSMs and is locked down properly, it's a very involved process. So you can only see the most motivated and well-resourced attackers bother to do this. And that's why pretty much everything there is a suspected nation-state attacker. And this is a reenactment of attackers signing their code in a compromised environment. So the next avenue is, let's just buy the certs, right? There's a huge business on the internet. There's tons of companies selling certificates. This is kind of how the internet works. Without SSL certificates, we wouldn't really have any type of e-commerce or secure communications on the internet. Same vendors also sell code signing certificates. Reversing Labs did a 6-part blog series last year that I would really encourage people to check out that goes into every piece of weaknesses in buying certificates. Really great blog series that has a lot of real nitty-gritty in how people are setting up fake identities. A lot of the domain control validation that these CAs do is pretty weak and easy to bypass. We're actually going to go through a few examples of that. Really, once again, we've placed a lot of trust in the CAs to make sure they're doing their job right. The CAs have to make sure that whoever's buying the cert is actually the person they say they are and are only using the cert for legitimate purposes. And the enforcement schemes for that are all post-fact. You have to realize that the cert's been used to sign malware, SSL certificates being used to host malicious C2, and then eventually take it back. There's not a lot of proactive prevention happening there. So a lot of trust and responsibility is placed in the CAs to varying degrees of effectiveness. So what the CAs have is something called domain control validation. This is kind of the standard of how they confirm that you control either a domain or, in the case of code signing, an email address associated with that domain. So they can say, okay, you are who you say you are because you have access to this. Obviously, this can be abused pretty heavily, and we'll talk about some of that in a little bit. So one of the ways that some of the CAs in the UK verify some of the information is through a public listing. In the UK, there's something called Companies House. It's a government-run database of all registered businesses in the UK. So if I go to register for a certificate in the UK, they're going to pull up my company name on Companies House, make sure the phone number, address, everything matches what I gave them, and then mail me a letter or ask me to fax them something from that number, determine that I control something that's in that listing. So what we usually see with the legally purchased piece is attackers are not directly buying the certificates. There are middlemen and illicit forums that are buying the certificates and then reselling them to malicious actors. And that's why this is kind of the first step in that malicious ecosystem. And just like a lot of the stuff we see, particularly in the last few years, in the targeted financial crime world, this has become a trend from the more mass spam botnet type of criminal malware activity. There's a malware as a service ecosystem where there's a lot of bits and pieces you can purchase, buy, lease from other criminal actors. So there's a wide economy there. So it's not really what we see more the nation-state sponsored groups do, which is where they're developing everything themselves or getting open source software. This is more collaborative. So the final question on legally purchased, and something that I'd encourage everybody to think about as they do pen tests, is how surveillance software, so things like Hacking Team RCS and other licensed entities that sell surveillance software around the world, as well as penetration testing firms, deal with code signing. So if I go to Thought or Sec2Go and want to buy a code signing certificate to sign my commercial surveillance software, should I have to tell them what I'm using it for and how it works? Most of these guys have a TOS that requires you to not lie on the information you're giving them, but we'll see some cases where that's not always happening. So here's the list of resellers I talked about a little bit. There is a large underground market for code signing certificates. And we've seen bits and pieces of it in our own research, but I would encourage folks to look at this report. There's a team out of the University of Maryland. They've actually done several reports on code signing in general. This is one they've done specifically for illicit resellers. They maintain a great website at signedmalware.org. This is a report they did specifically examining the marketplaces where you can buy code signing certificates. And what they found in the forum that they found, Code Signing Guru, all the certificates were issued to companies that were in this British company house listing. And they even had one of the owners of the forum claim that every cert that they would issue is listed on Companies House, so it appears like it's a legitimate business. And the interesting thing here is pricing. So certificates were available for as little as $400, which for a targeted financial attacker or a nation-state sponsored attacker is very cheap. And the high end was a couple $1,000s for extended validation certificates, but those wouldn't be needed in most of the use cases we're seeing here. So another way we see certificates. This is what I call glomming. And we don't really see this anymore. Used to see it quite a bit in years past. This was actually used by Eternal Petya most recently. Basically, it's where you would extract a public certificate from a legitimately signed file and use it and just append it to another file. This will fail all sorts of checks. It won't pass authentic code. Everything will tell you that this isn't actually signed properly. But what it will get you is probably a little bit of tweak on some machine learning and antivirus solutions that will weigh something that has a certificate a little bit less as malicious than something that doesn't have a certificate. And we actually talk about this a little bit in our blog that we released today on Fin7 and how they do malware signing, and we'll have a few more examples of that later. So this is a screenshot from our internal file signature analysis tool, and this is what a glommed or appended certificate looks like. It basically says, hey, this is garbage. And this is actually the output for the Eternal Petya sample that Kaspersky blogged about doing the certificate appending. And it's just going to tell you, hey, this is garbage. It's a Microsoft certificate. This is not a Microsoft file. And the reason that fails is part of the signing process is calculating a checksum of the file. So if you just pull the public key off another file and add it to a different file, it's going to fail that check. And that's the check that we're showing here. How else can I sign something? I just sign it myself. There's selfcert.exe in Windows. There's a PowerShell module for it. Basically, this is useful for software testing. This is really why it exists. However, we have seen some attackers do this. The key difference with self-signing a certificate is there's no trust chain. There's no certificate authority that said, hey, I trust this certificate. So any mechanism that's looking for that to exist is going to fail, which is all of them. And this is what a self-signed certificate looks like in our tool. It's going to say, hey, this wasn't countersigned by a CA. There's all this, the certificate chain is all self-signed. There's no certificate chain whatsoever. So this is going to instantly pop up in a lot of analysis tools as a self-signed file. So why would attackers bother with this? So real-world attack we saw with this is APT5. They had a dropper we call Brightcomb. They self-signed the final implant. But what the dropper would do is add the certificate to the local certificate store on the system. So this is another mechanism that's in place for things like testing. However, to Windows, it's transparent to the user if the key is in the root certificate store on the system or if it's an actual authentic code key that they're validating. So once the dropper installed the certificate as trusted in the local store, the malware could run without problems and would be transparent. Obviously, that would depend on system-level access to be able to write to the registry. And we even saw APT1 do this many years ago with the Pocket Twit Code cert, which was very popular for a time, signed warp malware, and we saw it reused for a couple of years. So we talked about executables. What else exists in the world of signing that we can sign? Macros. So macros is probably the easiest thing to talk about. The reason I'm showing this macro is because it looks like it's bad, but it's not. This is a legitimate macro, and credit to Nick Carr and Twitter for finding this one. The reason he found it is because it flags on a whole bunch of signatures we have for malicious macros. And it's interesting to talk about just because, like I mentioned earlier, the vast majority of macros in the real world are legitimate. They exist for a reason. They have a business case, as does this one. This one is doing a lot of stuff that we usually see malicious macros do. So it's checking the IP address. It's running commands out of ComSpec. It's running IP config. It's got guardrails for what IP it's coming from and what domain it's tied to. These are things we typically associate with malicious macros. But it's a legitimate one. It's from the Bank of Tanzania. It's checking that you're in one of their Windows domains. You're coming out of one of their IP spaces. So it's doing some built-in Visual Basic functionality to make sure that this spreadsheet is being run in their environment, and otherwise it wouldn't execute some of the additional functionality, something we call guardrailing. So the reason I bring that sample up is to show when we surveyed signed Office files, the vast majority of what we found was legitimate. So things like banks, financial institutions, a lot of places, insurers have a lot of business process that's built on macros. And that's mostly what we're finding. So we had to wade through that to find the bad stuff. This is a first example. This is a suspected financially motivated attacker we track as UNC766. They did several campaigns in 2016 and 2017 against newswire services and banks with a resume-themed lures with Powershell Empire payloads. And you'll notice this as a trend through the examples I go through. There's a lot of free pen testing frameworks that are being abused by bad guys in conjunction with the code signing. Here's the certificate they signed, and this is something we're going to see several examples of as well. There's a Polish certificate authority called CERTM, and they have a program to issue certificates to open source developers. Basically, the only controls that they have in place for this is that you have a valid email address that they can email you back to that you control. And did some more digging into CERTM, and we'll go into what their actual documentation looks like here in a bit, but we saw a lot of these, mostly because the barrier to entry was pretty low. So once again, we go back to the weakness in the CAs. Here's a little bit of what the macro itself looked like. It's probably a little hard to see, but this is just a bunch of strings that will concatenate to a PowerShell command that launches PowerShell Empire. Pretty common type of malicious macro that folks have probably seen a ton of. Okay, now we get into Fin7. Fin7 has been abusing code signing for a long time. We've been tracking Fin7 since 2015. Some of the earliest attacks in the first couple of years of tracking Fin7, they were heavily leveraging signed documents. So they would send signed documents with macros to their victims. This theme that you're seeing here persisted for quite a bit in terms of, hey, this is protected document, enable the macro to get it to run, and then it would launch their payload. Fin7 was kind of unique in that a lot of the lures would have 3 or 4 different payloads in them, and one of them is Cobalt Strike Beacon, which is another pen testing tool that they were abusing. And if folks are interested in what Fin7 is doing nowadays with code signing, we just put out a really good blog this morning about the most recent Fin7 activity that I'd encourage people to check out. So here's the company that was associated with the certificate for this sample, Network Software Limited. Once again, listed on Companies House in the UK, but I encourage people to look at the incorporation date if you can see it, 26 June 1986. So this company, or at least the listing for this company, has been around for a really long time. So how are these resellers abusing these existing companies to get certificates issued? So it goes back to the domain control validation. They have to have some piece of the chain of information that's associated with this company that they can subsume, whether that's an email address or a phone number. They have to be able to answer when the CA tries to call somebody at Network Software Limited. So that's something we're hoping to do a lot of more research into and how those controls are being abused. Here's a little screenshot of the initial dropper macro for this sample, and I'll zoom in on one part here. The reason I'm zooming in on this part is we can see here where they're setting up execution and persistence via WScript. So WScript is the Windows binary that runs Windows scripting host functionality. They're using WScript to launch a JavaScript payload here, Adobe Update Management Tool.js. The JavaScript payload in this sample itself is not signed, but the reason I wanted to highlight this is what the type of persistence you would see for signed JavaScript, which is, we'll go into some examples later. And here's another shot of that certificate, issued from Komodo this time. Komodo no longer is in the business of issuing code signing certificates or SSL certificates. They spun it off into a company called Sectago. So you'll see some Sectago issued certificates nowadays. This sample's a couple years old. So this was the eyebrow raiser. This is kind of like a little fun side diversion. The Office implementation for the ISO standard that defines how signatures are to be formatted for XML formatted documents defines a lot of really interesting stuff. So it tells you when the signature was signed, and my box got a little moved there, so it slided right through the date. But it tells you what time the signature was signed, which can be a really interesting pivot point in terms of looking at when the certificate was issued, when the document was created, and when it was signed. There can be huge gaps there that can be really interesting from an analytical perspective. And the second interesting part here is you get some metadata from the host machine that signed the document. So any Office file that's been digitally signed will have this metadata in it. You'll see that there's a comment where they can put in a comment as they're signing. That could be an interesting pivot point if you're looking at that across documents. But also, something really interesting here is it's putting in the number of monitors, Windows version, Office version, and the resolution and color depth of the system that signed this. Why it's doing this, I'm not quite sure, but it's interesting metadata if you're trying to do campaign and attacker tracking, particularly when you have like a weird resolution like this one, right? So 1672 by 1080 is not a normal monitor resolution. So the way we would see a strange resolution like this is frequently a VM. This is an indicator that this was signed in a VM, because if folks are familiar with VMs and use VMs a lot, when you resize any modern VM software, it'll set the desktop resolution to whatever you size that window to. So if you got a crazy weird resolution like that on a system, it's most likely a VM. So we talked a little bit earlier about penetration testing. This is probably the best example of a pen testing firm we found signing a document that was used in a pen test. We found a lot of these. I just chose this one because we figured out what company was doing it. Here's a certificate. We can see the subject issued here. This is through DigiCert this time, so not associated with the same illicit reseller that we've been talking a lot about. How many folks think Secure Publishers LLC is a real company? I thought it would be you. So we looked into this a little bit. Secure Publishers LLC is not a real company. We looked at the metadata for the file. It is blanked out here, but the last modified end publisher was a name that I blanked out. Same name is listed on Spokio as a senior information associate consultant at a company that I also blanked out that is in the same town that Secure Publishers LLC claimed to be in, which is Brookfield, Wisconsin. And the company listed on the Spokio listing is an actual pen testing company in Brookfield, Wisconsin. So if folks have looked at a lot of penetration testing and red teaming activity, the OPSEC bar is usually not there. They're not really worried about being identified or associated with the company they work in. The reason this is an interesting case is they are direct violation of DigiCert's terms of service by getting a signing certificate to a fake company. So, interesting case of red teams doing not so legal things. The next big one, we talked about this a little earlier, is Hacking Team. So Hacking Team, for folks who aren't familiar, is a commercial surveillance software vendor in Italy, disbanded a few years ago, or delisted by the Italian government, that was selling their RCS surveillance software to a lot of governments around the world. One of the better reports on this, and there are many, was issued by Citizen Lab, talking about stuff that they saw hitting Ethiopian journalists. And an interesting thing in this report is one of the few reports that talks about RCS being signed, is they highlighted a certificate signed to Mechunge. I'm probably butchering the pronunciation of that. We see that this certificate was issued through CERDM, through their open source developer program, the one we talked about that has not so great control validation mechanisms. So how many folks remember what happened to Hacking Team? And one of the reasons that they disbanded. It's because a hacktivist goes by the name of Phineas Fisher hacked them and dumped all their email out to WikiLeaks. So I looked for this in WikiLeaks. Here's the email, and here's all their certs. So they had an email in the dump listing all the code signing certs that they were using to sign RCS for customers. And there's our Mechunge certificate. And by the way, all these other certificates were signing tons of malware too, and not just PEs, but also documents. And here's the email with CERTM talking about buying some certificates, where they list the documents that are needed. So CERTM wants an ID card, driver's license, to confirm the identity of whoever's going in with the, for the certificate. Obviously, if it's a photocopy being sent, that's not the hardest thing in the world to make look like whatever you want it to look like. And here's CERTM's current policy, also asking for both sides of an ID card. And if you can't get an ID card, we'll take a notarized letter, or you can come to a CERTM ID point and tell us who you are with a utility bill. All this stuff is pretty easy to fake, and it is up for debate how much validation CERTM is doing when they get this stuff. So, example of a suspected Hacking Team customer using one of these certificates. They're using the Mark Chapon certificate. This is one of the certificates we just talked about in the leaked email. Unc345, also known as Dark Caracal, Lookout Security, did an excellent report on these guys a few years ago. And Lookout was able to, with pretty good confidence, attribute them to the Lebanese General Directorate for General Security. And here is, I don't have a screenshot of the document because it didn't have any Lure content. It was just a macro. But this is like a really simple macro that will just launch a message box with a link. And the user has to click on the link to download the malware. Why they signed it is up for debate, but they signed the document with the same Hacking Team certificate. Okay, real quick, I'm going to talk about Fin6 and JavaScript. JavaScript can also be signed. The primary criminal group we see signing JavaScript is Fin6. This is where it gets into some of the crime as a service stuff. We've seen some of the same things they're signing being sold and used by other criminal groups that are possibly affiliated. So I'd encourage folks who have access to our Intel portal to look for Bad Bulls, Venom, and Squidgate and Squid Sleep. Temp Metastrike is also using these same tools. But basically, we're seeing signed JavaScript payloads allow execution in an environment where Windows scripting host may be locked down. And here's the certificate. Once again, UK address, and there's the company's house listing. Interesting thing with Fin6 is they are also signing ransomware, and we're seeing a lot of targeted ransomware from Fin6 and other groups like Unc902, also known as Temp Warlock or TA505, using code signing certificates from the same source. So this is what a signature block in assigned JavaScript looks like. This is appended to the end, commented out sig, begin signature block. By the way, this is what a PowerShell signature block looks like too. It just has different comment delimiters. It's all base64 PEM format, so you can really easily decode that. And this is what the decoded JavaScript that they were signing looks like. If folks are familiar with Moregs or TerraLoader, which are some of the other names this goes by, this should look familiar. So, most excitingly, we found Turla using signed scripts. Turla is a suspected Russian state-sponsored group primarily active against diplomatic entities and military in Europe. In 2016, we saw a Shireen backdoor go to a target that they had actually phished several times before with unsigned versions of the same backdoor. So what it looks like is the target environment may have been hardened to only allow assigned JavaScript to run on endpoints. So Turla decided to try to bypass that mechanism by signing one of their scripts. Shireen is a heavily obfuscated JavaScript backdoor. It's really gnarly, pretty cool malware. We have excellent reporting on this on our Intel portal if folks are interested in more information on this campaign and Shireen in general. Here's a picture of what Shireen looks like decoded. This is just a little snippet. The reason I included it is because it has the version number in there, which we've been using for campaign tracking. And this is the certificate. And surprisingly, this certificate is also coming from a fake British company incorporated in 2000. So likely the same illicit reseller sources that we saw the financially motivated groups using, which was really interesting to see. So what are things that could be signed that we didn't look at? There's a lot. So Java packages can be signed. This includes mobile stuff like Android APKs. PDFs, browser extensions. So Mozilla and Google both ask for signing on browser extensions now. macOS, we talked about Gatekeeper a little bit. We have seen use of individual Apple developer certificates, which are the certificates that an open source developer for Apple can get, being used by APT32. So we don't know if they got them and registered for them themselves or they stole them from another developer that they'd compromised. And most interestingly, I didn't know about this before I was doing this research, is there is a standard Linux integrity measurement architecture to sign ELF binaries that we're hoping to do some more research into that as well. So how do I either stop these from running or at least identify samples that have certificates I'm interested in my environment and in public repositories? So for VBA macros and Office documents in general, there's very well documented group policy objects for anybody that's administering an environment where you need to run trusted macros. I would encourage researching this and making sure that you have the most stringent policy in place possible for your environment to allow business operations. If you do not need macros, just turn them off. Similar advice for Windows script host. There is no group policy control available, but there is a registry key you can set to enforce signature validation, and you can set that registry key via group policy. So slightly indirectly via group policy. But if you don't need it, turn it off. If you don't have any type of third-party application or business use case for Windows script host, just turn it off. You're going to break a lot of attacks. And here's some instructions on the registry key on how to just turn that bad boy off. So, Yara, the power of Yara, right? We all know, we all love it. We can use Yara to identify code signing certificates in a wide variety of formats. So prior to doing this research up until about a year ago, we were really only looking for these in PEs and onesie, twosie, and some other formats. With the help of Aaron Stevens, who you guys saw yesterday, we developed a way to generate signatures automatically that can look for certificates across a wide variety of formats. And what you can do with these signatures, and what I would encourage anybody who is in an environment where you are signing code, is deploy signatures for your certificates in repositories. Look for them popping up And if you see them signing something that is not yours, you have a problem. So we developed a tool within our AP Tools tool set to generate YAR signatures that we've extracted from scripts, documents, and binaries, PE binaries. The interesting thing to mention here, and I talked about it a little bit in the JavaScript section, is for Office documents and JavaScript, the certificates will be base64 PM encoded. If people are familiar with how base64 works, any given value can be represented in base64 one of 3 ways. So you take that, you multiply it by line breaks, you have a fixed amount of ways that any byte string can be represented in base64, and you can use that to build YAR-SIGs, really long YAR-SIGs. So this is an example of looking for all the possible base64 variations of a serial number of a certificate. And the reason it's so long and there's so many variations is just like what I said earlier. There's 3 different ways any base64 encoded string can be represented, and then you have line breaks, and that's why you have 23 per variation. The interesting thing in here, if folks are up on their Yara, there's a couple variables defined here for CRLs. Aaron found this when we were doing the initial research, that there's some archaic formats, such as Adobe Air, that embed CRLs into every package that is created in Adobe Air. So there's like hard-coded certificate revocation lists. So we decided to just not look at those. And what you see in the second screenshot is the second rule, and this is what you would do just to look for the certificate in OLE, which is the older Microsoft Office document format, as well as PEs. So you're just looking for the bytes for the serial number and the CN, the common name. So we'll be releasing code for this script in an accompanying blog post in the coming weeks, so folks can automatically generate their own Yara signatures for any code signing certificates that they may be interested in monitoring. I just want to give special thanks to a lot of folks who helped out with this research. Aaron, who you guys saw yesterday, Andrew Thompson, Rick Cole, all on the Tor Advanced Practices team, and our compatriots in Flare. Troy Ross is the person that developed that file signature plugin that you guys saw some screenshots of. Really has been super useful for us. And Todd, who you also saw yesterday, and Jay Gibble, both helped us extract certificates automatically at scale from a large sample set. So real team effort on this research, and wanted to make sure I thanked everybody. I think I have 2 minutes for questions if anybody has questions.
So you talked a little bit about how you can sign code, or you can use certificates to sign PEs, JavaScript, PowerShell, but can you use the same certificate to sign multiple different types of files, or do you have to get a separate certificate for each one? How does that work?
So, really good question. The question was, can we use the same code signing certificate to sign many different types of file objects, so executables, JavaScript, documents? Yes. And we actually had a couple examples of that, like the hacking team stuff. We initially found those certificates signing executables, but then we pivoted out and found the same certificates signing documents. A lot of the FinSix stuff that comes from those malware as a service type of offerings, they use the same certificates to sign an executable dropper as well as the JavaScript it dropped. So that's where the script that Aaron developed comes in handy, is we can pivot from a certificate that I saw on an executable to finding JavaScript or documents that were signed with the same certificate by having those multiple YAR rules that look for the variations between file formats.
Did you find any distribution of bad CAs and all the data that you looked at?
Yeah, so I know I talked a lot about the culpability of the CAs and like kind of mismanagement there. There's not truly bad actors. I think it's more negligence than maliciousness. I think the maliciousness comes in those illicit resellers that are fraudulently getting certs. And as you go back in time, the negligence got worse. Like that first example I talked about the Malaysian government CA that just wasn't doing anything, basically. So that system has gotten a little tighter, particularly on the SSL side. We haven't seen as much on the code signing side that there's been pressure for the CAs to get a little bit better on stuff. I predict that that's going to be happening in the next couple of years with the explosion in ransomware that's signed and some of these venues for the illicit reselling.
I missed the first couple of minutes of this, so I apologize if you covered it already, but do you have any statistics for what % of malware is signed?
That's a great question. I do not have statistics available, but there is a great repository I talked about a little bit called signedmalware.org. It's a research team out of the University of Maryland that's done several research papers on the overall problem. They're a little bit more focused on wider things like potentially unwanted programs, PUPs, not necessarily targeted malware like I was talking about, but they've found really large amounts of not legitimate software that's being signed. And they're the ones who also did a really good paper last year on some of the illicit resellers.